Today, let's get to know the types and functions of sensors in electronic control technology of diesel engines. Please watch the PowerPoint presentation while listening to my explanation. The sensors on electronic controlled diesel engines can be described as diverse and varied, roughly divided into three categories: pressure sensors, temperature sensors, and speed and position sensors, with subtypes numbering around a dozen. Today, we will introduce the sensors that are essential for most electronic controlled diesel engines. First, let's look at the high-pressure common rail structure diagram. Now, let's learn about the sensors commonly used in electronic control systems of diesel engines. 1. Crankshaft speed sensor. Structure: magnetic pulse type. Installation: located on the flywheel housing, next to the crankshaft pulley, or on the engine block. Function: primarily used to measure engine speed and crankshaft angle. 2. Camshaft position sensor. Structure: magnetic coil type. Installation: located at the front end of the camshaft. Function: provides a signal to the ECU every time the camshaft completes a revolution, allowing the ECU to determine the piston of which cylinder is at the top dead center of the compression stroke. 3. Common rail pressure sensor. Structure: pressure resistance type. Installation: mounted on the common rail. Function: real-time measurement of actual pressure in the common rail and feedback to the ECU for adjusting fuel pressure. 4. Coolant temperature sensor. Structure: negative temperature coefficient (NTC) thermistor. Operating range: 40 to 130 degrees Celsius. Installation: located on the thermostat. Function: measures engine coolant temperature to precisely control fuel injection quantity. 5. Intake pressure sensor. Structure: semiconductor piezoresistive pressure sensor. Installation: positioned at the intake manifold. Function: calculates the air volume to control the air-fuel ratio and the negative temperature coefficient (NTC) thermistor, thereby further precisely controlling the fuel injection quantity. 6. Fuel temperature sensor. Structure: negative temperature coefficient (NTC) thermistor. Operating range: 40 to 130 degrees Celsius. Installation: positioned on the main fuel pipe. Function: provides the engine control unit ECU with fuel temperature signals. The ECU uses these signals to adjust the fuel injection quantity based on temperature changes. This adjustment is necessary because fuel expands and its density decreases as temperature increases. 7. Oil temperature sensor. Structure: negative temperature coefficient (NTC) thermistor. Installation: positioned on the main oil pipe. Function: provides engine oil temperature to the engine control unit, especially in cold temperatures. 8. Water temperature sensor. Installation: located on the engine water outlet pipe. Function: measures coolant temperature for fuel injection, torque adjustment, rail pressure correction, and thermal protection. 9. Atmospheric pressure sensor. Installation: integrated within the ECU. Function: detects atmospheric pressure, measures altitude, and adjusts fuel injection parameters. 10. Mass airflow sensor. Installation: positioned after the air filter and before the turbocharger in the air intake pipe. Function: measures incoming air volume for fuel injection quantity adjustment. 11. Throttle pedal position sensor. Installation: located on the throttle pedal. Function: measures pedal travel to reflect the driver's intent for fuel injection calculation. 12. NOx sensor. Installation: positioned on the engine block. Function: Detects engine combustion status for precise pre-ignition control. 13. Water content sensor. Installation. Mounted on the coarse filter. Function. Detects water content in fuel and alerts the driver for timely water prevention. The electronic control system of diesel engines electronically controls the fuel injection system to achieve real-time control of fuel injection quantity, timing, and conditions during operation. The electronic control system collects signals from sensors such as engine speed, temperature, and pressure, synchronously inputs the real-time detected data to the ECU, compares it with stored parameters, calculates the optimal values, and controls the actuating mechanisms such as fuel injection pumps, exhaust gas recirculation, glow plugs, etc., to drive the fuel injection system and optimize the operation of the diesel engine. Finally, let's ponder a question. What are the differences between diesel engine electronic control technology and gasoline engine electronic control technology? That concludes today's lesson. Goodbye, everyone.